Have you heard? There's a new Mars rover, and it's the latest piece of NASA's puzzle that is understanding the red planet. I'm Anna Marie, and today I'm going to talk about InSIGHT. InSIGHT, or the Interior Exploration Using Seismic Investigation, Geodesy, and Heat Transport Rover, launches on May 5th from California. InSIGHT is a terrestrial planet explorer that was created to answer one fundamental question. How were the rocky planets in our solar system formed? Let's break this rover down a bit, though. First is interior exploration, specifically meaning that we're focusing on what's below the surface of Mars. Seismic investigation, looking at how the core and ground of Mars is moving, just like people look at earthquakes here on Earth. Geodesy, the math dealing with the shape and area of a planet. Heat transport, looking at how heat moves through the planet. This is all pretty complicated and very vague, though, which is why InSIGHT has 6 specific missions. First, determine the size, composition, and physical state of the Martian core. Second, determine the composition and structure of the Martian mantle. Third, determine the thickness and structure of the Martian crust. Fourth, determine the thermal state of Mars's interior. 5, measure the magnitude, rate, and geographic distribution of Mars's internal seismic activity. And 6, measure the rate of meteorite impacts on the Martian surface. But how's it going to do this? Technology, of course, from all around the world. First is SEIS, or the Seismic Experiment for Interior Structure, which is basically a seismometer that's going to be measuring Mars quakes and other internal activity. Next is HP3, which is Heat Flow and Physical Properties Probe. Think of it like a mole with a really long tail that's going to dig itself 5 meters straight down into the surface of Mars, with temperature sensors every 10 centimeters or so along the tail. These sensors are going to measure the temperature at various places in the soil, and along with the knowledge of what the soil is made up on Mars from other rovers, it'll let us know how much heat is escaping from the planet. Next is RISE, the Rotation and Interior Structure Experiment, which uses a radio link to track signals sent from Earth that'll pinpoint the exact rover location on Mars. And since the rover is not going to be moving, this will allow an exact tracking of how fast the planet is spinning, and any changes in that speed. Finally, we'll have cameras, so we know what we're looking at. Now, why does this all matter? Because it's all going to give us a better idea of the history of Mars and how it was formed, which will give us a better idea of how Earth was formed, and how Earth will behave in its future.